this is part 140. It's line 18A, 3y, Fast Neutrinos Reactors CRESST, Opera, CNGS CERN UFO 5G Wow Seti. I didn't get to finish my thoughts and tags from the previous video, so I'm going to go backtrack to that one. And let's see, stopped here. Okay, so what we were talking about is the electron and positron. And this came up. Dave Goldberg is the author with Jeff Bloomquist, A User's Guide to the Universe, Surviving the Perils of Black Holes, Time Paradoxes, and Quantum Uncertainty. And then you follow them on Twitter. Okay, and you can ask physicists at io9.com. So February 17, 2012, I just left a comment on his blog to let him know I'll be showcasing his article in this video. Dave features an article about Taylor Wilson. He built a nuclear reactor at age 14. I wonder if he can help with this neutrino UFO engine idea. Just a thought. And here are the tags for this video. The previous video. So all these videos in this section here you want to take a look at anyways if you're looking for the 5G force formulas. This one's got a lot of data at the beginning of it because I didn't know what the words meant. And then at the end we have another formula. So please bear with me. So this is part 140. There's the Wow Seti signal. It talks about a breeder reactor is a nuclear reactor capable of generating more fissile material than it consumes because its neutron economy is high enough to breed fissile from fertile material like uranium-238 or thorium-232. Again, the uranium-238 came up quite a bit. There's a nice little picture for you to look at. Here's another one. This is liquid metal cooled fast breeder reactors. I wanted to see what they do, what they look like. So I googled it. So what they can do is extract almost all of the energy contained in uranium or thorium, decreasing fuel requirements by nearly 2 orders of magnitude compared to traditional once through light water reactors which extracts less than 1% of the energy. In principle, breeder fuel cycles can recycle and consume all actinides, leaving only efficient products. Good moderators are also free of neutron absorbing impurities such as boron. So I just pulled out some thoughts. It was quite lengthy what came up, and what I'm doing is just pulling out what I thought we could use. This is Wiki from Neutron Moderator. Again, all these comments and links are going to go up on the Victoria Stafford A Psychic Investigation website on WordPress. So this is a fast neutron reactor, meaning one with little or no neutron moderator. And hence utilizing fast neutrons can be configured as a breeder reactor, producing more fissile material than it consumes using fertile material in a blanket around the core or contained in special fuel rods. Since plutonium-238 and 240 and 242 are fertile, accumulation of these and other non-fissile isotopes is less of a problem than in thermal reactors that cannot burn them efficiently. Okay, so it's talking about the different fuels and what they can do with them. And this came up here. It's called CRESST, C-R-E-S-S-T, Searching for Dark Matter. This is a new thing that they're working on, brand new for 2012. With the CRESST experiment, physicists from around Europe are searching for a new form of matter, the dark matter. This is believed to be the missing matter of the universe. To search for this matter, novel detection methods operating at very low temperatures have been developed. Some of them are almost like minus 200 degrees, some of them are minus 400 degrees, so they really cool it down. Found out more about this exciting field at the cutting edge of particle physics and cosmology, its application in other fields of science, or have a look at our latest publications. If you have questions or inquiries, you want to contact them. Status: currently the experiment is ongoing at Gran Sasso, which is the same place that they're testing neutrinos, underground laboratory in Italy. The latest setup contains 17 detector modules, which partly also implement new detector technologies and concepts in order to further increase the sensitivity of the experiment. So if you want to contact them, you email wimp@crest.de. and they work for the Max Planck Institute for Physics, CRESST group, and it looks like it's in Germany. There's their phone number, and there's their website. Okay, February 19th, my thoughts. I've heard so much info about neutrinos from bloggers and didn't really know where to look for the actual data. I actually have been looking for it, but nothing was coming up. So this is cool that this came up now. This is great. I found the actual site, which is mostly written in Italian. Not sure of the language. It could be German. This explains what the experiment was and what the results were. They cannot explain it yet. So basically they have these results, test results, but they're still trying to figure out why they have the results. How interesting that it has come up so many times in this alien Wow Seti signal. Maybe it's the universe's way of shaking things up. Makes you want to dig deeper. In this case, I think you all need to stop looking at your past equations and look for a new one to explain why this is working. Looks out of the box of the norm. Since it's an interesting test result, I have an idea for you. What is the level above sea level for your facility? I got about, sorry, typo. Is it different where you're located compared to the other facility testing neutrinos in Japan? Bell, I think that's the name of the place. Or it could be anything. I remember reading about quarks and how they change from positive to negative. I've read that neutrinos can morph into other particles. It's like human particles. When we hang out with another person, we pick up their mannerisms, and I believe we tap into their biorhythms of their body and connect as one. Even the Bible states that the two shall become one, not meaning because of marriage, but because our bodies synchronize with one another. I know they do. I've tested this in my own personal life. Two people that spend 24 hours a day, almost 7 days a week, develop each other's bodily habits. Eating? No, we don't develop the same eating habits. We don't have the same appetite. Feelings of pain and discomfort are synchronized? Yes, that's true. The bowels are synchronized? Yes, that's true. The bathroom times are not. The way the body decays, eyes, ears, synchronized. What I'm trying to say is this. Dark matter is a reflection of what it contains, a mirror image of itself. A neutrino is connecting to whatever other particles are in it with it during the test. The laser beam it travels along heats it up and excites the molecules. So they split into 4 quarks and double the energy or speed of your neutrino? Am I correct? Did you notice the speeds excited matter going 50% faster after you collide them with a wall? Quarks return to the wall or atoms and they bounce off other atoms. I'm not sure about the terminology there. I did read about it, so I'm assuming that's what it was. And it causes them to split again. I think your neutrinos are splitting into 4 quarks. You cannot see the other 2 particles because they are smaller and undetectable. According to these Wow Seti formulas, you want to add the neutrinos to cold plasma and liquid argon gas. If you cannot use liquid argon gas, pick a particle found in it that will split. The neutrino will mimic its movements and mirror them. Publish your results and let me know if this idea is right. So I got another photo for you. It's called Measurement of the Neutrino Velocity with the Opera detector and the CNGS beam. Pasquale, Migsoli, and INFN Napoli. September 26, 2011. So I pulled a quote from them. The Opera result is based on the observation of over 15,000 neutrino events measured at Gran Sasso. It appears to indicate that the neutrinos travel at a velocity 20 parts per million above the speed of light, nature's cosmic speed limit. Given the potential far-reaching consequences of such a result, independent measurements are needed before the effect can either be refuted or firmly established. This is why the Opera collaboration has decided to open the result to a broader scrutiny. The collaboration's result is available on the preprint server arxiv.org. That's the link. This result comes as a complete surprise, said Opera spokesperson Antonio Arrenditito, sorry if I'm saying your name wrong, of the University of Bern. After many months of studies and cross-checks, we have not found any instrumental effect that could explain the result of the measurement. While opera researchers will continue their studies, we are also looking forward to independent measurements to fully assess the nature of this observation. When an experiment finds an apparently unbelievable result and can find no artifact of the measurement to account for it, it's normal procedure to invite broader scrutiny, and that is exactly what the opera collaboration is doing. It's good scientific practice, said CERN Research Director Sergio Bertolucci. If this measurement is confirmed, it might change our view of physics, but we need to be sure that there are no other more mundane explanations that will require independent measurements. In order to perform this study, the opera collaboration teamed up with experts in meteorology from CERN and other institutions to perform a series of high-precision measurements of the distance between the source and the detector, and of the neutrino's time of flight. The distance between the origin of the neutrino beam and opera was measured with an uncertainty of 20 centimeters over the 730-kilometer travel path. The neutrino's time of flight was determined with an accuracy of less than 10 nanoseconds by using sophisticated instruments including advanced GPS systems and atomic clocks. The time response of all elements of the CNGS beamline and of the opera detector has also been measured with great precision. He says, we have established synchronization between CERN and Gran Sasso that gives us nanosecond accuracy, and we've measured the distance between the two sites to 20 centimeters, said Daria Oterio, the CNRS researcher who will give this afternoon's seminar. Although our measurements have low systematic uncertainty and high statistical accuracy, and we place great confidence in our results, we're looking forward to comparing them with those from other experiments. The potential impact on science is too large to draw immediate conclusions or attempt physics interpretations. My first reaction is that the neutrino is still surprising us with its mysteries, said Erudito. Today's seminar is intended to invite scrutiny from the broader particle physics community. The opera experiment was inaugurated in 2006 with the main goal of studying the rare transformation or oscillation of muon neutrinos into Ta neutrinos. One first such event was observed in 2010, proving the unique ability of the experiment in the detection of the elusive signal of Ta neutrinos. February 19th, 2012, my thoughts. Keywords to remember. The neutrinos travel up to a velocity 20 parts per million above the speed of light, so it's above the speed of light, nature's cosmic speed limit. My thoughts continued. Based on what I wrote before, reading all the CERN documents from Gran Sasso's neutrino test results, I say we take the liquid argon gas particles that split and cool them down and add them with neutrinos. Then you want to collide them to find out if the neutrinos are splitting into 4 quarks. Look for evidence of smaller particles. Add a few degrees of warmer mist to it and it should show up. Kind of like you blow hot air on a cold window, then draw happy faces in it. You can see the trace of your fingerprint on there. I did a Google on particles and found in liquid argon gas, and came up with a test result from D.W. Swan from 1965. Funny that most theories and test results are either from the 1960s and 1970s or in recent years. So this is the article that came up. It's Proceedings of the Physical Society, Volume 85, number D.W. Swan, 1965, and ionization of liquid argon by a particles. Abstract reference cited by, from an analysis of electron pulses in liquid argon produced by A particles, the average energy required to form an ion pair is evaluated. Assuming Jaff's theory of columnar recombination is valid. The mean value of 26.0 eV found in this way agrees well with the corresponding value of 26.4 eV for particles in argon gas. Applications of Jaffe's theory to the liquid state is discussed, and from the pulse distributions it is established that the experimental results are in good agreement with this theory. So it's 61.80 long ion radiation effects, and it says last time viewed. There we go. And there's the website, iopscience.iop.org. Okay. My thoughts. You want to take the ions and use a sputtering gun invention, which was mentioned in earlier videos of line 18A. By using slow laser beam pulses, you can excite the neutrinos to make them split by using leptons and protons in the mixture. Collide them all together and see what happens with the neutrinos. I'm going to give you my theory. The neutrinos will match the highest energy of whatever particle excites the most. And that's what I think is going to happen. Hope you guys let me know if it does. Okay? So that's the end of that video.